At the core of trigonometry, there are three basic trig functions: sine, cosine, and tangent. The easiest way to describe these functions is to relate them to a right triangle. So here we have a right triangle with an angle of theta. So this side will be labeled A, this will be B, and C will be the hypotenuse. So then sine can be described as the ratio of B to C, or the opposite side to the hypotenuse. So sine of theta is equal to B over C. And then cosine of theta can be described as the ratio of the adjacent side to the hypotenuse. So cosine of theta equals A over C. And then finally, the tangent of theta can be described as the ratio of the opposite side to the adjacent side. So tan of theta equals B over A. Using this, we can derive some formulas for sine, cosine, and tangent. So now we have the Pythagorean theorem: a squared plus b squared equals c squared. And now we can divide both sides by c squared. So we would get a squared over c squared plus b squared over c squared equals c squared over c squared. And then this becomes, since we know that a over c is equal to the cosine, we can rewrite this as cosine theta squared plus sine theta squared, because b over c is equal to the sine of the theta. And then finally, c squared over c squared should equal 1. And now we get the Pythagorean property, which says that the square of the cosine plus the square of the sine of an angle must equal to 1. So if you have one or the other, you can calculate the one that you're missing. And then finally, we have the relation of tangent to sine and cosine. So you know that tangent is equal to b over a. So then if you divide the sine by the cosine, sine theta is equal to b over c, and cosine theta is equal to a over c. So if you divide b over c by c over c, the two c's cancel out, and then you get b over a, which is just the tangent right there. So you can express this relation as such: tan theta is equal to sine theta over cosine theta. However, this is a bit problematic when you have angles that are either negative or they might be equal to 90 or above 90, because if you have a right triangle like this, if this angle equals 90, you can't really make a triangle. Or if this angle exceeds 90 like this, you can't make a triangle either. So it's hard to express angles that are not acute angles in this format.
Because of the inadequacy of using just a right triangle to model and make use of sine, cosine, and tangent when dealing with negative angles, or other angles greater than or equal to 90 degrees, one can utilize the unit circle. The unit circle is a circle with a radius of 1, whose center is at the origin of a Cartesian plane drawn like so. So here is the x-axis, and here is the y-axis. Here is a circle. A right triangle can be drawn like so. To show how the right triangle relates to the unit circle, with this angle as theta. The cosine of theta, which is an angle at standard position whose initial side lies on the positive x-axis, and whose terminal side lies anywhere else on the plane, which happens to be right here, and is equivalent to the x-coordinate of the point on the unit circle that is formed by the intersection of the terminal side and the circle, which is this point, or the length of the right triangle. The sine of theta is equivalent to the y-coordinate of the same point, or the height of the right triangle. So here, x is equal to cosine of theta, and y is equal to sine of theta. And the tangent of theta is equivalent to the value of the y-coordinate over the value of the x-coordinate, or the slope of the hypotenuse of the right triangle. So here, y over x is equal to tangent of theta. Knowing that the radius of the circle is 1, we see that the trigonometric ratios hold true when you try to find the sine of an angle of 90 degrees, like so. Once again, here's the y-axis, here's the x-axis. Here's the 90-degree angle, and here you can see that the length of the radius, which is 1, is equivalent to the sine of said angle. And the length of the radius is also equal to the cosine of an angle of 0 degrees. So here, the radius of 1 is equal to this angle, which you can't see because it's 0 degrees. So therefore, the radius is equal to the cosine of 0 degrees, and the radius is also equal to the sine of 90 degrees. As an example, if we know that the sine of a certain angle is 0, and the cosine of a certain angle is -1, we can use the unit circle to find that angle. If we draw the unit circle, we can see that point P on the circle here has coordinates -1 and 0 on the Cartesian plane. So, in order for it to be a Cartesian plane, you indicate that it's y-axis and x-axis. So, this means that the sine of this angle is 0, and the cosine is -1. So, as we can see, the angle is a straight angle, which has a measure of 180 degrees.